Question number 6. Combustion, formation are given. Which of the following is the standard enthalpy change of formations of hexane? Okay. Now first of all, please look at your target equation. This is your target. Standard enthalpy change of formations of hexane. Therefore, the first step you must do is to write down the equation. Hexane with formula. Now for Form 4 students, you haven't learned how to change the term to formula. But for Form 5 students, you should understand. Hex means 6. Alkane means belong to CnH2n plus 2. Therefore, H14. Hexane is a liquid at room temperature. Formation, that means hexane is the product. When 1 mole of hexane is formed from its elements are graphite and hydrogen. Next, you need to balance this equation, very important, okay? 6 and 7. Now, however, the data given, 2 of them are formation, 1 of them is combustion. Now, maybe I copy down first. This data is given. Formations of carbon dioxide is given. Formations of water is also given. Now look at the data. The data given, 2 of them are formation, 1 of them is combustion. Then we cannot use this equation because while you're using this one or this one, all the data given must be formation, combustion, understand? However, I have talked about a trick. Do you remember? Standard heat of formations of carbon dioxide actually is equal to the combustion of graphite. They are the same because they have the same equation, so they have the same value. Formations of water is equal to the combustion of hydrogen. Now maybe I explain these two again. First of all, do you remember what is formations of carbon dioxide? It refers to this equation. When it is the enthalpy change when 1 mole of carbon dioxide is formed from its element. Its elements are graphite and oxygen. Next, according to the definition, we need to keep this as 1. Okay? Next, balance. How about combustion of graphite? Combustions of graphite refer to the enthalpy change when 1 mole of graphite is completely burnt in oxygen to form carbon dioxide under standard conditions. Again, keep this as 1, then we need 1 O2 and form 1 CO2. Now let's compare these two. They are the same. Can you see that? In other words, heat of formation of carbon dioxide is exactly equal to the standard heat of combustion of graphite. Do you understand? Similarly, for standard enthalpy change of formations of water, when is the enthalpy change when 1 mole of water is formed from its element. Its elements are O2 and H2. Keep this coefficient as 1 because the definition required this as 1. So we need to put half before O2. How about standard enthalpy change of combustion of hydrogen? Is the enthalpy change when 1 mole of hydrogen is completely burned in oxygen to form water under standard conditions. Keep this as 1. Then we have 1 water, and then we need half O2. Now again, compare these two. They are the same with the same equation. Therefore, this value is equal to another value. So would everybody please copy down these two relationships? Copy down these two. This is the first one. Bear in mind, this is another one. Now after that, you can change all the data given to combustion, combustion, combustion. Is that right? So we can use this equation to work out the delta H, which is the summation of standard enthalpy change of combustion of reactant minus combustions of product. Okay? And then is equal to the difference between these two terms. First of all, look at the reactant. We have 6 moles of graphite. So 6 times, for each mole it is negative 393.5. Now we have 6 mole. Plus we have 7 mole of hydrogen. 7 mole of hydrogen. For each mole, the delta H is, therefore multiply them together. Minus the standard enthalpy change of combustions of product. Look at the product. We have only 1 mole of combustions of hexane, which is negative 4194. Lastly, the answer, kilojoule per mole. So the answer is B. Do you understand? So please bear in mind these two terms. Moreover, bear in mind this equation. Okay, try your best.